Today what we're going to do is we're going to graph a pair of equations and determine the number of solutions, okay? So in the first one here, I have y equals 2x plus 1 and y equals 2x minus 3. I'm going to go ahead and graph it, and then I'm going to determine the number of solutions, and then if there is a solution, what the solution is. So I'm going to go ahead and graph the first one, y equals 2x plus 1, so I'm going to go ahead and start at positive 1. The slope is 2, so I'm going to go up 2 and right 1, up 2 and right 1. I'm going to go the opposite way from the start, down 2, left 1. So here's my line from that one. I'm going to go ahead and graph the other one, y equals 2x minus 3. So I'm going to start at negative 3, which is down here. I'm going to go up 2. I'm going to go right 1. I'm going to go up 2, and I'm going to go right 1, up 2 and right 1, up 2 and right 1, down 2 and left 1. All right, I'm going to go ahead and draw that line. I noticed something when those two lines are drawn, that they look parallel, and because those lines are parallel, this would be an example of a no solution. Okay? Because again, these are parallel lines. I can look at the equation and also determine whether or not it's no solution. How I do that is I look right here at the slope. If we take a look, the slope of both equations is 2. As a result, that tells me that they're going to go up, or in this case, they're going to go up by the same amount each time. I notice also that they start at different points. Because they start at different points and have the same slope, I know also that it's going to be a no solution. So let's go ahead and look at another one. Number 2. This one's a little bit different. I have this one in slope-intercept form, y equals 2x plus 1, but this one is not in slope-intercept form. So what I need to do is I need to change it into slope-intercept form. So I'm going to go ahead and write this one down, okay? Y minus 3 equals 2x minus 2, I believe, all right? And now what I need to do is I need to change it so that it is in slope-intercept form. So y equals mx plus b, okay? So I need to get the y by itself. In order to get the y by itself, I have to add 3. I add 3 to both sides. Notice that I'm going to add 3 to the minus 2 because those are the like terms. This cancels out, so this is solving equations. Y equals 2x, a negative 2 plus 3 gives me a positive 1. As a result, I get y equals 2x plus 1 in slope-intercept form. So I'm going to go ahead and write that over here. So y equals 2x plus 1. So that is what this one right here is in slope-intercept form. So I'm going to go ahead and graph that first line. I'm going to go ahead and go to y-intercept of 1. I'm going to go up 2 and right 1, up 2 and right 1. I'm going to go down 2 and left 1, down 2 and left 1, down 2 and left 1, because that's the opposite. I'm going to go ahead and graph that line for you. Now I'm going to go ahead and graph this one, y equals 2x plus 1. So I'm going to go to the positive 1 again. I'm going to go up 2 and go right 1, up 2, right 1. I noticed something. These would be the same exact line. So this is an example of an infinite solution. Or infinite solutions, sorry. Okay? Because if I look at the equations, this has the same slope and the same y-intercept. So when the slope and the y-intercept are exactly the same, we're going to end up with an infinite solution. Okay? Let's look at another one. So I got y equals negative 2x plus 3. And 2y equals 4x plus 6. So again, I noticed that this one is in slope-intercept form. This one is not in slope-intercept form, so I need to change it into slope-intercept form. So what I'm going to do is I'm going to copy it down on a piece of paper. 2y equals 4x plus 6. Double check to make sure that was the right equation. Okay, so now I'm going to go ahead and change that equation. So I want it to say in slope-intercept form, y equals mx plus b. So in order to get y by itself, I'm going to have to divide by 2. So I'm going to divide each of this by 2. So I'm going to take this and divide by 2, which gives me y. And then I need to take this whole side, and I need to divide the whole side by 2. So I take 4 and I divide that by 2, which is 2x. I take 6 and I divide it by 2, which gives me 3. So it's still a positive 3, so I'm going to do a plus 3. And so now I have slope-intercept form. So I'm going to go ahead and write that one down over here. Y equals 2x plus 3. So that is what that one is in slope-intercept form. Okay. So now I'm going to go ahead and graph both lines. So I'm going to start with this first one. I'm going to graph negative 2x plus 3. So I start at positive 3. The slope is a negative 2x. So that means I'm going to go down 2 and write 1. I'm going to go down 2 and write 1. I'm going to go down 2 and write 1. Down 2 and write 1. If I go the opposite way, that's up 2 and left 1. There's my line graphed. Okay. So now I'm going to go ahead and graph the other one, y equals 2x plus 3. So I start at positive 3. I follow the slope of positive 2 over 1. So I'm going to go up 2 and write 1. I can't go up and to the right anymore, so I'm going to go to the opposite. Down 2, left 1. Down 2, left 1. Down 2, left 1. Down 2, left 1. I'm going to go ahead and graph that line, draw that line in there. I noticed that those lines do intersect, and they do intersect only once. So as a result, this is going to be a one solution. And so now I need to identify the x and the y coordinate of that one solution. Okay? So I look at what is my x value. So right here is this. So I'm going to look at my x value. So I look down here, and the x value right here would be 0. I look at my y value, and I've colored it up, but my number between my 2 and 4 would be 3. And it's going to be a positive because it's above the origin. So it's going to be 0, 3 is going to be my one solution. All right.